Okay guys, this is actually the video for percent mass to molality. This should help with 12.68a. So we have an aqueous solution containing some percent by mass of a random element, and I'm still abbreviating that RE. Doesn't matter what it is, and I'll explain why. So you need to calculate the molality of that, and then the mole fraction of the solution. So that'll be like part A and B. So the percent by mass, it's like if I said that this was 20% by mass of this random element, that means that there is 20 grams of the random element per 100 grams of water. Okay? So then, and you have to make sure that you label like the masses and then what it's of, otherwise this is going to get really messy. And you have to do that for everything else. So the next thing that you would do, because we want to cancel the grams of the random element, is we want to actually use the molecular weight of that random element. So that's why I said it didn't matter, because you can just use this template to set up any equation. Because we know that we want moles of random element on the top and kilograms of water on the bottom. That's why we do this. So we do 1 mole of the random element, so we end up with that on the top over whatever the molecular weight of the random element was. So that cancels, and then we just do the algebra. So you'll fill this blank in yourself. Anyway, and then we want kilograms of water on the bottom to get molality, since molality is in the units of moles of whatever the element is, and kilograms of the solvent, which in this case would be water. There's 1,000 grams of water per 1 kilogram of water. You just do this algebra and solve for the molality of the random element. It's really fast. So then if we want to go from the percent mass to the mole fraction, it's even easier. So if we have the percent mass of the random element that's aqueous, which means it's in water, by the way, in an aqueous solution. So all that means is whatever this random element is, it's probably ionic, it's probably dissociated, it's in water. Okay, cool. So if it's NaCl, like we were given for that problem, and you can actually call this random element, because it doesn't matter what this is. Actually, here, let me cross this out so you guys can follow along. So however many grams of the random element that you guys have, that was the percent. So if this was 20% over here, you would put the 20 grams of the random element. And you multiply that by 1 over the molecular weight in grams of the random element to get how many moles of the random element you have. Then, if you guys have, you assumed 100 grams because of the percent by mass of water, because that's what it's in. So there's 1 mole of water for every, 1 mole for the molecular weight of water. It's like 18 point something. So you guys would just fill that in if it was water. Or it could be some other solvent. So you just solve for the moles of water. So then your mole fraction is just the moles of the random element over the sum of the moles of water plus the moles of the random element. And that'll give you some number, and it's unitless. So nothing goes after this. Write that on your note card for the test. But that ought to help. Hope you guys have a good Saturday.